In this video, we will be looking at building a full-stack D app with React and Ethereum. In this task, we will be using React as the frontend and Ethereum for the backend. We will be introducing full-stack D apps and what are its benefits. Then we shall set up the development environment which requires tools and frameworks such as Ethereum, Web3.js, and Truffle. We shall then create a new React project. Then we will connect React to Ethereum with Web3.js, which is a popular Ethereum JavaScript API. Then we shall write, compile, and deploy the smart contract. Then we will be interacting with the smart contracts in React. Then we shall build the React frontend and test and deploy the full stack DApp. Full stack DApps combine a decentralized backend on the Ethereum blockchain with a user-friendly frontend built with modern web technologies like React. This combination provides a seamless user experience, whereas having additional security and transparency of blockchain technology. It is like constructing a building where blockchain is the foundation, whereas all the features of the building is provided by React. We require Node.js and npm again. This time we need to install Truffle. Truffle is a development framework for building dApps on the Ethereum blockchain. It provides tools and libraries to simplify development, including smart contract creation, testing, deployment, and management. Then we install Ganashe CLI. It enables you to connect to a local blockchain for testing your dApp. To create a new project, we use the create react app command to set up the initial project structure and necessary dependencies. We can look at the commands here to create the app. MyDApp is the name of your project. Then we use cd myDApp to navigate to the project directory. It can be equated to setting up the initial framework of a building. Now we shall connect React to Ethereum using Web3.js. Web3.js is a popular Ethereum JavaScript API which helps in connecting backend with the frontend. First, we need to install Web3.js in the React project. It is like setting up the electrical wiring that connects the building systems to the power grid. Then we create a file named web3.js in the src directory and configure web3.js. This file will handle the connection between React and Ethereum blockchain. This web3.js file will detect the available web3 provider, whether it's an injected provider like MetaMask or a local Ethereum node. This ensures the app can communicate with the blockchain. This code is an example of the web3.js file we create. The getWeb3 function attempts to create a Web3 instance by checking various sources for an Ethereum provider. It first imports Web3 library, then the getWeb3 function returns a promise. A promise in JavaScript represents an operation that can be pending, fulfilled, or rejected. It then waits for the web page to fully load by adding an event listener for the load event. It then checks for window.ethereum, which is injected by the app's browsers, like MetaMasks, if it exists. If it exists, a new Web3 instance is created. Then the function attempts to request account access from the user. If the user grants access, the promise is resolved. If the user denies account access, the promise is rejected with the error. If modern DApp browsers are not found, it checks for older DApp browsers which use Windows.web3. If both do not exist, it falls back to the local host. This is useful for development environments where a local Ethereum node is running. Let us write and compile smart contracts. First, we write a smart contract using Solidity, compile it using Truffle, then deploy the contract. This is like designing the blueprint and constructing the core infrastructure of the building. The steps to write and compile a smart contract file is to create the smart contract file in the contract directory and then use the truffle compile command to compile the project. It is necessary that the smart contract be in the contract directory. To deploy the smart contracts, we first write the deployment script in the migrations directory. This script tells Truffle how to deploy the smart contract to the blockchain. Then we shall start Ganesha's CLI, which will provide a local Ethereum development environment for testing and deployment. Then we run the deployment command given. This will deploy the contract to the local Ethereum network. Let us interact with smart contracts in React. We shall integrate the deployed smart contract with the React frontend using web3.js to enable interaction with the blockchain. It is like connecting the building's control systems to the infrastructure to enable interaction. Here is an example of the interaction code. Here we are first importing the necessary React library. Then we also import the getWeb3 function which we had written earlier. Then also the JSON file which contains the information of our smart contract, message contract is also imported. Then we create state variables, Web3, accounts, contract, message and new message to manage their states within the component. Then the use effect hook is used to initialize Web3, get user accounts, get the contract instance, and fetch the initial message from the contract when the component mounts. Then the handle change updates the state new message when the input field changes. Handle submit sends the new message to the smart contract and updates the displayed message after the transaction is confirmed. Now we shall build the React frontend. This is to create a user interface for interacting with the smart contracts. It involves creating components, managing state, and handling user input. This is like creating control panels and display screens on the building. We create components to represent different parts of the user interface, such as forms, buttons, and displays. Then we manage state. We implement state management in React to keep track of the application's data and user interaction. State management serves as a container that encapsulates relevant data, logic, and behavior within a component. Then we handle the user input. We capture and process user input such as form submissions, button clicks, and other interactions and update the application state accordingly. Testing and deploying the full stack DApp. First, we run the DApp locally with the command npm start. Then we test its functionality and ensure all its features work. Then we use the truffle migrate network option to deploy it to the testnet. Then we update the configuration and ensures it connects to the testnet. Then we use a React app to host the DApp. Test the full stack DApp locally to ensure it functions correctly. Deploy the DApp to a testnet or mainnet for real world use. This testing and deploying the full stack DApp is like conducting final inspections and opening the building for public use. We got to know that full stack DApps combine a decentralized backend on the Ethereum blockchain with a user friendly front end built with React. Then we also saw how we need to write and deploy smart contracts and build the React front end. Then we also looked at the testing and deploying the full stack DApp to ensure it functions correctly and is ready for real world use. These are some questions which you can solve.